Happy New Year, everyone. This is Andrew Kimmons with Kimmons Toolworks, and today I have a handful of new things here that are really cool. And I've been excited about this for quite a while and just kind of being quiet about it. I had these finished up before Christmas, but I had a huge, a lot of random odds and ends to get done in the shop. I had like something like 12, 13, 14 tools, every single one of them different, kind of highly custom and complex, that I've been trying to bring together over the last couple of weeks, and a lot of that's going to start shipping. But anyway, this will be the first video of some of the new things, and I'm pretty excited about it because, to the best of my knowledge, nothing like this currently exists out there. So, and after we go over that stuff, I do have a couple of updates on my wife's health stuff for anybody that is curious. I've had a handful of people ask, and we've learned some interesting things about that. So I'll talk a little bit about that. And all right, so let's get right into this. Draw knives. I have been asked to make draw knives since I've started, and even by family members and things like that. It's been highly requested. And my thought with the draw knives was, yeah, it's cool, I want to do it, but I want to do something different. I want to do something unique. I mean, the world has enough normal. That's why it's normal. I want to do something different, and something that's has good utility to it, because draw knives are cumbersome, and getting a good precision edge on them may not be the easiest for everybody, and I have a solution to that. And this took a lot of tinkering and a lot of R&D on my part, but I've arrived at that. And let's go ahead, and I will pan the camera down and we'll talk about these. Now, we have 3 different draw knives, all the same size. These are the small size ones. I intend to make these in at least 3 different base sizes. But basically, what we have here is what I'm calling a modular draw knife, where you can take the blades out to sharpen them. Furthermore, you can have multiple blades sharp on hand. Also, if you want to switch to a different style of blade, you can do that with the same handle set. And they're very simple. Actually, they're not simple to make, very simple to use. This one's in black and white ebony, and then we have one in electric blue curly maple, and then one in regular curly maple. Basically, it's a pretty simple system, and I really wanted to nail the ergonomics on this. The ergonomics are very important with such a thing, and you can see how this kind of comes together to be very ergonomically correct. And even the way the ferrule hits on your finger, I mean, this is by far the most comfortable draw knife I've had my hands on. And see, this is the original one that I had a customer request. He said he just wanted a small size draw knife. I said, okay, that's cool. He's been a good customer since the beginning. I told him, I said, it may take me a little while to figure out exactly what I want to do, but I'll do it. And we talked a bit about the angle of the handle, excuse me, and how a lot of them on the market are either too straight or like at a 45, and really somewhere in between is optimal, particularly since, I have bad wrists, so that right there, that motion, having this at the right angle makes a big difference, because it takes very little to make my right wrist hurt very badly. So I went with this design here, and the tangs on these are all the way down into here. And like I do, I machine these deep ribs on them, and then they're resined in place with a ridiculously strong flexible epoxy. So this is very much a permanent attachment, and you can see it's very, very cleanly done. And these handles are a little smudgy, but these portions right here, the machining on that was pretty complicated, and those had to be bent, obviously. But it's as simple as this. If you want to take the blade out, it just takes a 5/32 hex key, and you have to be careful not to cut yourself. I do see how one could cut themselves doing this, and then you just break them loose. Take the screws out. I even had to custom machine these screws to fit this properly, so these are a lot of work. I could not find the perfect size screw, or bolt should I say, because it's a little more like a bolt than a screw. But you take those 4 screws out, and then the handles slide right off, and then you have the blade, and it's very easy to sharpen these blades. This is a 30-degree bevel, and for a draw knife, all you really need to do with this, and it's very easy to lap the entire back, the whole back's lapped, because what I do is I take one of my DMTs just because it's flat, and these don't have to be 110% perfect like a small chisel edge, and I put a piece of 1500 grit wet dry sandpaper, like a silicon carbide sandpaper on it, and I just spray it with a little bit of oil. Do this, flip it, do this, you know, just get it to where it's nice and lapped, good to go. And all I do then is take it, and you can just put your thumbs on that and just perfectly ride the bevel and do it freehand, and these just get ridiculously sharp that way. Way, way, way sharper than a draw knife even needs to be, and it's very simple. And you know, there's the blade. That's all there is to it. And you can tell that with these handles, they're countersunk for the screws. There's a machine slot threaded on the back, and I left the circular pattern from machining on these surfaces because I thought it looked really cool. It's polished still, it's not rough, everything's polished, but and then obviously to put it back together, and I do recommend using a little bit of oil because this is carbon steel. A little bit of oil helps very much, especially if you're working with wet wood. Moisture getting up in that could definitely cause some corrosion. But the reason why we use carbon steel at all for woodworking tools is because it functions better. Stainless is very fragile compared to carbon steel. That's why stainless steel varieties aren't used for these applications. I know a lot of people actually wondered that, like, why not just use stainless? Well, because you can't get away with it and keep the performance. And a steel like A2 can perform absolutely fantastic, almost perfect for woodworking, if heat treated properly. And let's see here, that, tighten this up. It's very, very simple. And now you do want to make sure that these get torqued properly. You don't want to leave this loose. And it doesn't take a lot, just enough. And I also wanted to talk a little bit about, I was heat treating some CPM M4 before New Year's vacation. And I have a lot of people ask me about doing cryo on A2. And so I figured I would explain why that's not necessary and when cryo is necessary and what cryo is used for I'll pan up to myself while I'm talking about this. So I want to talk a little bit about what it's used for and what it's actually used for and what corporations that use it for. Because most of the time, dependent on the steel that they're marketing, a lot of times it's just that. It's just marketing. Because they throw the word cryo in there and it makes it, ooh, that's fancy, it must be better, I want that. And in a lot of cases, now there's a case where that can be true. So we'll start with A2, for example. A2 steel is a medium alloy tool steel. And the whole point, what you're trying to achieve with heat treating, is you're converting a type of material, steel structure called austenite into martensite. And the whole idea is to get the most efficient conversion possible, to convert all of it, ideally. That's the whole idea, is you're actually distorting the grain structure of the steel. What happens is you're heating it up enough for carbon to melt into interstitial spaces of the grain so that when you quench it and it freezes, it distorts and it puts stress into the material and it makes it hard. Hence why you would temper it afterward, is you try to relieve a little bit of the stress, that way it's not fragile. Now, A2 has absolutely no trouble efficiently converting into the martensitic, type of steel that you need for cutting. Some steels do not convert efficiently, and in instances where you have a really high alloy steel that has issues converting completely, that's where cryo comes in. And cryo is used essentially as an extension of your quench. And a lot of people don't do it right. They'll temper and finish with cryo, and that's not how you do it. The whole concept of cryogenics is when you have a high alloy steel to start with, and you take it from its austenitizing temperature, you take it out and you go to quench, however you quench it, that's up to you. With most of these high alloy steels, like tool steels, you're just shooting to rapidly get below 1,000 degrees. It's like once you get below 1,000 or 900 degrees, it's like you don't have to rapidly cool it anymore. It's actually not good in a lot of cases to cool it rapidly downward from 1,000, because that's where you get cracking. So, because with high-speed steels, oftentimes, they can be operating at 1,000 degrees and they don't soften whatsoever. That's the whole point. Why lathe tools are made of high-speed steel. It's so that they can handle a high temperature without softening. So that's the way I look at quenching these steels. It's like once you're below 1,000, it's better to just kind of let it go, because you get more warpage too. It's like if you rapidly, like with A2, you have to rapidly go below 1,000, continue through 1,000, and you have to go down to, in the hundreds, because A2 isn't a high-speed steel. See what I mean? So those higher temperatures will affect it. But with a steel like M4, you get it down below 1,000, good. You just let it still air cool down from 1,000. And from that point, if you were going to use cryo, once it's down to room temperature, you would subject it to deep cryogenics, which is very cold, like liquid nitrogen cold. That's considered deep cryo, whereas shallow cryo would be in the negative hundreds, negative 120, whatever. I honestly don't remember. But I don't use shallow cryo because it's useless. So, and I don't use deep cryo because I have no reason to, and there's a reason why. Anyway, but if you were going to employ cryogenics on M4, what you would do from that point is then put it into a type of a cryogenic chamber that will slowly bring the temperature down to negative 300 and whatever liquid nitrogen is. I don't remember. And the point of that is being used as an extension of the quench. So you come down from the austentizing temperature, you go down to 1,000, you end the rapid quench, and then you let it cool in still air from 1,000 down to ambient temperature, and then you would subject it to cryo and continue that quench. And the point of continuing that quench into the realm of deep cryogenics is to continue to distort the steel matrix, and it causes a more efficient and thorough conversion into martensitic steel, which is usable steel, for steels that have a hard time converting. That's what cryogenics is for. It's to take the cutting edge, no pun intended, the cutting edge of steel technology in the world of CPM steels with really high alloy. And if you employ a pretty basic heat treatment process like you would in mass production, you're not going to get a thorough conversion into usable steel. So you would add that quench extension of cryogenics onto it to further convert the retained austenite in the steel to the martensitic structure that you need. So that's what cryo is for. Why it's stupid on A2 is because A2 has absolutely no trouble whatsoever thoroughly and efficiently converting into usable martensite. And there's plenty of information out there. You can look into it. Like and it's all about, this is where it's all about getting it right to start with in the actual heat treatment, is because if you perform the heat treatment right, which may take a lot of tinkering to figure out how to get this efficient conversion, but if you do it right, it makes cryo useless. Like, why? You have nothing left to convert. There's nothing left to convert. So that's the whole idea with A2, and why I absolutely, it would be a waste of time, waste of money, and I'd have to raise the price of my products to employ cryo, and you would get nothing out of it. Like, they were seeing, I think in the studies that I was reading on it, they were getting like nothing to maybe a 1% increase in toughness. And it's like that when you get down into the 1% range, it's like, hey, even heat treating in general is plus or minus 1 Rockwell point, which is huge. It's massively more than 1% in overall performance. So I don't even know how they would conduct that accurately whatsoever. But long story short, low alloy and many of the medium alloy steels don't need cryo. It's a waste of time, and if you feel you do need cryo for A2, what you actually need to do is get your heat treatment process right from the start. So it's really that simple. I know this turned into a little bit of a rant, but I have people ask me about this still, and so I figured I would just do it here where people can learn. Anyway, there are some steels that do benefit from cryo, and where it's not just BS marketing. And that is largely in the realm of high alloy CPM steels that get a cookie cutter sort of mass production heat treatment. Like cryogenics, you could employ cryogenics on CPM M4 successfully and actually lower your tempering temperature by half. And that works, oddly enough. But the thing is, you don't need that. Not if you get it right. Not if you know how to do it. I have spent at least 2 years tinkering with and learning exactly how to get that conversion with CPM M4 without cryo. Like, you can do it. You can absolutely do it. And you do not need cryo for that application. I can't say that of all steels. Nobody can. Because it's different person to person, day to day, piece of steel to piece of steel, even though the quality control is extremely good. But yeah, so that's what I have to say on cryogenics and how it's largely used for marketing and not actually used for performance, unless the heat treatment process being used and the steel being used come together in such a way where cryogenics is beneficial at all. So anyway, I hope literally anybody out there got anything out of that. I love my short little rants. I rant about everything. But anyway, back to what we're talking about here, because there's more. But wait, there's more. Let me show you. There's something about regular curly maple that I love. It's so classic. And you can see too, I wanted to point this out, that actually has a curve backwards, a slight backwards curve to it, and I like that. And you can still see some of the grind on the edge, because I figured, you know what, I'm not gonna waste usable steel. That looks good. And you know, these things are they're just killer. They're just freaking killer. And that electric blue is always fun. I love that stuff. I have a CPM M4 electric blue framing chisel going together today, and I'll do a video with that too, because it's super cool. And he's been waiting quite a while for it, but because of my wife's health issues, I've had a handful of things, you know, take a little longer than I like. But anyway, we have another mini screwdriver. This is the mini version, and this is the first time we've seen one in regular curly maple. And these are made for the screws on your bench plane. So yeah, if you have my chisels or my tools or whatever and want a screwdriver to match your planes for hand tool woodworkers, you can do that. And this is the long version of it, the full length version in black and white ebony. And this actually is a custom size. He wanted it in 70 thousandths, and I nailed it 70 thousandths. Let me go get my micrometer. It's freaky. For this kind of stuff, if I have a customer that wants something in a very, very particular size, I don't use dial calipers. I use calibrated Starrett micrometers. And because I want to get it right to the absolute best of my ability. And dial calipers are not nearly as accurate as a micrometer that measures into the 10 thousandths. Yeah, check this out. I mean, I don't think we're even a 10,000th of an inch off. I don't know if you can see that. That's just ridiculously accurate. It would appear as though, yeah, we're not even a 10,000th of an inch off. This is accurate down to probably close to 100,000th of an inch. So I take accuracy very seriously, and this actually goes along with this, and this has been a really good customer that's been with me since the beginning, and he's similar to me in that he appreciates accuracy. So I was like, you know, I like to go all out. I don't like normal. There's plenty of normal in the world. So anyway, these are all things now that you can order by emailing me at Kimmons or Andrew at kimmonshandtools.com. All you have to do is just shoot me an email and tell me what you're interested in and looking for. Pretty much my whole list of things. I make like 200 different things, all the chisels, everything. You can order those anytime. Andrew at kimmonshandtools.com. Or, you know, tell me what you want, what you're looking for, or if you have something weird and custom in particular that you want. And a lot of times, unfortunately, those highly custom things are very expensive to do, but that's because there's a lot of associated tooling and figuring things out a lot of times that make it that way. But anybody that wants one of these modular draw knives, send me an email. Andrew at kimmonshandtools.com. Let me know. Or the screwdrivers. And also, I was going to show everybody that I have an updated version of the scraper now, and it's in G10. And check this out. I think that's a 5/64 hex key, and you can just unscrew them and interchange them, or like take them off and use it without those, because a handful of people like to use them flat for things. So yeah, I actually was using this yesterday, and I love this little thing. I was fixing a door in the house and recutting the strike plate for the door. It had to go back like another 1/8 of an inch, and I took this thing up there and it just cut the most perfect little line. and then moved it back. It was excellent. So anyway, I hope everyone likes this, and I hope somebody at least was able to get a little insight from my cryogenics rant and what it's for and what it's not for, and how it's used a lot of times, and how it's used isn't necessarily always for improvement of a material. It is extensively used to market products, and in some cases not. But chances are, if it's a basic low alloy or medium alloy steel such as A2, it's marketing. You're not going to get anything from Cryo. So anyway, I hope everyone has a happy new year. And once again, if you want any of these types of things, and you can also, I wanted to mention too, I'm going to do these in 2 different sizes. So if you like this but want a medium or a larger one, that's doable. And also the same handle options of kind of whatever you like apply to that as well. So Andrew at kimmonshandtools.com, and happy new year out there, and I will see everyone next time.